These are your 10-3C notes, simplifying radical expressions once again. And so this time we're going to talk about how do you get rid of a radical when it's a binomial in the denominator. So just looking at this lovely simplification checklist one more time, and you can notice, I think on your sheet of notes, it didn't come out at all, those first two check marks. I'm really not too concerned with them. That's why they're grayed out. I am really going to focus on this third rule here that says that there are no radicals in the denominator of the fraction. And so that's the rule that we're going to concentrate on today. A lot of the similar things that we've already worked with, it just builds upon what we did yesterday. And so to rationalize the denominator one last time, and it's just a method to use to eliminate a denominator. It makes the denominator a rational number. So we already did that. And so just to review that concept, in 10-2, we said that this is a fraction. Can't have a fraction under the radical sign. So we fixed that rule. And now we have a radical in the denominator. And so I'm going to multiply both the top and bottom by the square root of 3 to make it a perfect square in the denominator. And you end up with the square root of 24 over the square root of 9. And we know that the square root of 9 becomes 3. And I can actually clean up 24. And so 24 becomes 4 and 6 over 3. And the square root of 4 becomes a 2. And so what we end up with is 2 root 6 over 3. We just fixed all 3 of those checklists. I got rid of the fraction. I got rid of the radical in the denominator, and I took the perfect square root of 4 out of 24. So we're going to build upon that today, but we have to do it a little bit different today because sometimes that process of just multiplying the denominator by itself does not work. So before we begin the whole process, I have to define some things. A conjugate is a binomial term, and it's used to rationalize denominators involving binomial radical expressions. So when you have a radical in the denominator that is a binomial, then you use a conjugate to get rid of it. And so to give you an idea, if a plus b, that's a binomial, is the original, a minus b is its conjugate. If a minus b was given, then a plus b is its conjugates. So they are conjugates of each other. So the idea is they are the same exact terms, but the middle signs are opposite. So that's why they're not called opposites, because in order for them to be opposites of each other, you have to have opposite signs of both the a and the b values. So only the middle sign is opposite. So let's just practice that concept. So the conjugate of 3 minus x is 3 plus x. Same exact terms, the 3 goes in front, the x goes in the back, and you just change the sign in the middle. The conjugate of x plus 5 is x minus 5. And the conjugate, this is the type of thing that we'll be dealing with in the denominator, of 2 minus the square root of x is 2 plus the square root of x. So now that I hope you have a good grasp of what a conjugate is, we're going to use it. So in this first problem, I just want you to pay attention. I don't want you to write this down. I want to show you why we can't just multiply by the square root of 3. Okay, a little bit different than what we did before. So don't write this down. I just want to explain. To get rid of the square root of 3 in the denominator, which is the issue here, if you multiply by the square root of 3, you have to multiply this whole entire thing by the square root of 3. And when you distribute, you'd get the square root of 9, and then, or negative, and then 6 root 3. So you multiply the 6 by the square root of 3 and the square root of 3 by the square root of 3. That's great. It did take care of the square root of 3. It made it a 3. But all it does is moves the square root of 3 over to the 6. If you did it again, it's just going to move it right back over here with the 3. So it's not going to fix it. How we fixed these before is not going to work. Okay? And the difference is it's not 6 times root 3 that we're dealing with. It's 6 minus root 3. And so it's a binomial. And the only way you're going to get binomials to go away is if you multiply by the conjugate. So the conjugate of 6 minus root 3 is 6 plus root 3. We did a few of these multiplications on yesterday's homework. And what you notice is when you have plus the square root of 3 and minus the square root of 3, we kept crossing off those middle terms. And the other thing that happened, not only did the middle terms cancel, the last term turns into a perfect because it's the square root of 3 times the square root of 3. It's going to be perfect. So this will eliminate a radical. Whatever you do to the bottom, though, we also have to do the top. So I'm going to multiply both top and bottom by 6 plus root 3. So on top, I'm going to distribute a 2 through. 2 times 6 is 12. And 2 times root 3 is positive 2 root 3. So my numerator is 12 plus 2 root 3. In the denominator, it's going to require to FOIL. So I'm going to take this 6 times 6 makes 36. 6 times root 3 gives me a positive 6 root 3. Negative root 3 times 6 gives me a negative 6 times root 3. And last terms, it's a negative root 3 times a positive root 3 makes a negative root 9. So now we can clean that up. So the very first thing I'm going to clean up is I'm going to cancel out these because a positive 6 root 3 and a negative 6 root 3 makes 0 root 3s. The square root of 9 becomes 3. That's a negative 3. And so the negative 3 and the 36 is going to make 33. So I have 12 plus 2 root 3 all over 33. I look at my final answer. There's no fractions under the radical. There's no radical in the denominator. And the square root of 3 is as simple as it can get. And that's the process. So a lot of repeat of what we've already done. So number 2, we need to multiply by a conjugate in order to get that square root of 2 out of the denominator. So I'm going to multiply both top and bottom by 5 plus square root of 2. Whatever you do to the bottom, you must also do to the top to keep it equivalent. Distribute the 3. 3 times 5 is 15. 3 times root 2 is a positive 3 root 2. Then when we FOIL, first terms, 5 and 5 make 25. Outside, positive 5 root 2. Inside, negative 5 root 2. And last will be a positive and a negative root 2, which gives me a negative root 4. You will always have a negative sign, subtract a perfect at the end. And your two middle terms should always cancel. If that doesn't happen, you did something wrong. So the positive 5 root 2 and this negative 5 root 2 cancel. The square root of 4 becomes a 2, but we're subtracting 2. So when you subtract 2 from 25, we end up with 23. So I'm going to put that in the denominator, and I'm going to put 15 plus 3 root 2. And that there is my simplified answer. All right, we're going to try just a couple more, but we're going to make it a little bit more complicated on top when we get to number 4. Actually, I'm going to skip number 3. Let's go on to number 4. So to do number 4, I have 4 plus root 3. We're going to multiply it by 4 minus root 3. So I just want to show you when you have more than one thing up top. Sometimes you'll have a binomial on top, so you'd have to FOIL the top and FOIL the bottom. So I'm going to distribute. Now remember, when we distribute, outside numbers get multiplied and inside numbers. Here, 4 is an outside number, 2 is an outside number, 8 root 3 minus 2 root 9. Square root of 3 times the square root of 3 makes square root of 9. I'll deal with that later. On the bottom, first terms gives me 16. Outer gives me a negative 4 root 3. Inside terms gives me a positive 4 root 3. And last gives me a negative root 9. So when I go to clean this up, I'm just going to clean up a few things. Cancel out my two ugly middle terms. They cancel each other out, a positive and negative 4 root 3. The square root of 9 on top becomes a 3, but that 3 needs to be multiplied by this negative 2. And so I have a negative 6. I'm just going to write it there for right now. Square root of 9 becomes 3, and I know it's a negative 3. So when I clean up the top, I have 8 root 3 minus 6 all over 16 minus 3, which is 13. And that's our final answer. All right, so it's your turn. I want you to give me the conjugate of 2x plus 5 as your lesson summary. And then I need you to simplify. So figure out what you'd multiply by to get rid of that denominator, to rationalize that denominator. Good luck.